So hopefully after watching this video, it will make more sense about how we have to find if the slope is positive, if the slope is negative, if it's zero, if it's the word that I can't say. What is that word? You can't say that in my class. We can write it down, but we can't say it, okay?
To answer the question.
Okay, let's get back to this. As usual, we start with the definition. So we're going to talk about slope for a while. So, on graph of linear relationships, slope describes the steepness of a line. Slope is the ratio of the vertical change compared to the horizontal. Good job. Change. Or, I'm sure all of you remember rise over run from 8th grade. The slope is equal to the rate of change. These are not a new thing, right? You guys heard these a lot last year. Yes, that's a good thing, Doc. It's okay, that's why we're going to go over it and refresh your mind. So, like the mountain video that we watched, guys, like the mountain video of a slope dude that we watched, this is like going up to the hill. So, if that's going up, is it positive or negative? Positive, because it's going up. So we went to the up. We went to the top of the mountain. Now we're going down.
That's negative.
That's negative. Negative what? What are we talking about here? The slope. Good job. Now, we're just walking.
Zero.
That would be 0. And we're falling. That word that we can't say it, but we can write it down, right?
Definition.
There you go. So, this is very obvious. We worked on this last year a lot. So, positive, negative, 0, the word that we're not allowed to say in a math class.
Hey, can we spell it?
No, why is that word so bad anymore?
So that way you can remember.
Can we spell it?
Okay. So, guys, let's focus here. So, let's say you want to find rise over run, right? Or find a slope on a graph. We pick 2 points, then we count, and we say rise over run. We're going to work on that on the graph when we get there. And then the third part is reduce the fraction, or you can just type it in a calculator. What do we mean by that? Let's take a look at the next page. Okay.
I remember how to do this.
You remember or you don't remember?
I remember.
Okay, perfect. So first we said we have to pick 2 points. For example, here it picked 2 perfect points for us, right?
Make it a triangle or something.
Yes. And then we count our rise over run. How we do that? We do it like this. We start from 1 point. We choose 1 point to start from there. Perfect points. It already showed us the 2 perfect points on this one, right? Then we said rise over run, right? I'm trying to get from this point to that point. First is rise. So I'm going to rise. Yes. and then we run. The arrows are so important because it shows our direction, if it's positive or negative. So when we're going up, is it positive or negative? It's positive. How many house I moved? 2. So I'm going to say 2 positive. Then I'm moving to the right. How many house did I move? 3. I'm moving to the right. Is it positive or negative? Positive. So positive 3. Remember, this is the positive direction. This way is negative direction. So, now we said we're gonna reduce the fraction. How we do that? We said we pick 2 points, then we calculated rise over run, right? I want you guys to write this down somewhere on your note. So, what is your rise?
2.
2. What is your run? 3. Now, did I find my slope? Yes. Do I need to reduce it?
No.
No, it's already reduced. So I'm going to say my slope is 2 over 3. Does that make sense? Is that refreshing your mind now?
Yes.
Okay. Now let's do the second one. Let's find 2 perfect points. Perfect point means that we are not allowed to find a point here or here. We just allowed to find a point on the perfect part, which is here on the cross of these 2 lines that cross each other. And it's lay on this graph. So I'm going to choose this one, and I'm going to choose that one. Am I allowed? Yeah, these are 2 perfect points. Now I'm going to do my, yes, I'm going to do my rise over run again. I'm going to see how I'm going to move now. I'm going to start from this point to get to this point. I'm going how many houses up? 1. Is it positive or negative? Positive. So I'm going to put positive 1 here. And then I'm moving how many houses to get to the other point? 2. Is it positive or negative? Negative. Good job. So in this case, how many was my rise? 1. And how many was my run? Negative 2. So basically I have negative 1 over 2. So my slope, I can't reduce it more than this, right? So it would be negative 1 over 2. Or, yes.
How would it be negative 1? I thought it was negative 2.
It doesn't matter because this negative at the end when you reduce it, which this one is already reduced, it belongs to both of them. It's a negative point. Okay? Now let's do this one. Do I have to choose 2 points on this?
No, because
It's the one that we're not allowed to say the name, right? But we can write it down, right? So let's just write it down. So it is okay, guys. You guys had enough fun. Okay, let's talk about this. Let's read it. Can somebody read it for me?
Oh, goodness. Clark loads boxes of paper on a pallet before shipping them. The graph shows the linear relationship between the number of boxes of copy paper and the weight of the pallet. Find the rate of change with the pallet weight with respect to the number of boxes.
Yes. So, it says find the rate of change. What is the rate of change? The other name for slope. So let's just write that down. I'm just going to write it down here. Slope is the other.
That says slope.
Oh, sorry guys. Slope is the other name for rate of what? Change. Good job. So anytime you see rate of change, you should know they're looking for the slope still. What do we do in a slope? We find two perfect points, and then we do rise over run, and if it's possible, we reduce it. So, for finding the slope, we're going to say again, M equals rise over run Let's find it. We have 2 point already indicated for us. So I'm going to start from this one, for example. I'm going to say my rise is here, and then my run is here to get to this point. How many houses did I move? And is it positive or negative? Positive. So can I just put 2? And how many houses did I move this way? 1, 2, 3, 4. Is it positive or negative? Positive. So okay, so over here we made a mistake. We made a mistake because I didn't see that these are count by 10. So that's 20, 30, and 40. So we're going to say how many we moved? 20.
What?
Do you see that? 20, 30, and 40? So it would be 10, 20. So this is 20. And then we have 10. Well, this one is just by 1. So 1, 2, 3, and 4. Do you see that? So this is a great example to show you that not all the time when you see the units here, it's sometimes can see different units here. Okay? So pay attention to that. I kind of forgot and I didn't look at it. So in that case, what is my rise here? 20. What is my run? 4. So 20 divided by 4, because we still have to reduce, right? It would be 5. So the answer is 5 pound per boxes. So I'm going to show it like this. Pound per box. Because the units here starts by 10. So 0 to 10, 10 to 20, 20 to 30, 30 to 40. Do you see that? Okay. Now let's move to the second one. To the last one. Okay. On that one, I'm going to leave that one for you guys to do it. Okay. So let's move to the next. Let's glue that to your notebook before we forget and date it. Today is what? October 6th. Good job.